Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. Question is which carboxylic acid has lowest pK? So I request you student, please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. So question, which has lowest pK means which is strongest acid. What do I mean by strongest acid? Means which one can release proton maximum efficiently. Who can release proton maximum efficiently? For that, whose conjugate base is more stable. What is conjugate base? If you remove the proton from this molecule, whatever anionic part is remaining, that is called as conjugate base. So let's look at the conjugate base. And remember the thumb rule, higher the stability of conjugate base, higher is the acidity. So here conjugate base, if you look at, so let's draw the conjugate base of this molecule. By the way, these all are aliphatic carboxylic acid. So this is, now you can see here hydroxyl group is there and carboxyl group is both are there. So here who is more acidic? Obviously carboxylic acid. They are more acidic compared to alcohol. Now so here actually difference is student the ring carbon number. So right now it is 1 2 3 4, so 4 hydroxy carboxylic acid, or sometimes it is called alpha beta gamma. Okay, so that's I'm named, so this is alpha beta hydroxy, this is alpha hydroxy, in this way. Now so these are the conjugate base. Now what is uniqueness is there, or is there any specific stabilization factor? Yes. If you look at carboxylic acid, this propionic acid, these group result plus I effect only. Here all group results plus I effect. But if you look at this carbon, it is not that much donating. Why? Because electronegative oxygen atom is attached there. So the donation is less. Point number one. By the way, who can stabilize carboxylic group? The group which have some electron withdrawing effect. And who can destabilize? The group which have some electron donation effect or plus I effect. So plus I effect is here responsible for the destabilization of the conjugate base. And in this molecule, means option B, the plus I effect is less. So obviously indirectly it is stabilizing. Second thing, these hydrogen can form an intramolecular hydrogen bonding. Remember student this term. Why it is intramolecular? Because the hydrogen bond is actually inside the molecule. So that's why it is called intramolecular hydrogen bonding. And it is responsible for stabilizing this conjugate base. What does it mean? Actually, if you look at these hydrogen student, so this hydrogen is delta plus because it is attached to electronegative atom oxygen, means little electron deficient. These O minus have some excess electron density. So their cooperation or weak bonding among them will result stabilization for both. So that's why it is stable. If you look at, now you can say, sir, this is also possible. Why? Because here 1 2 3 4 5, so 5 member ring formation possible. Then same logic, 1 2 3 4 5 6 member ring formation. Student, that does not give, it doesn't give that much. Now how? If you draw a 6 member ring, it should look like this way, this. Okay, so if you say these 1 carbon 2 3 4 5 6, now look at these 1 and 6, they are far away compared to, if you look at 2 versus 6. Okay, so let's understand this. 2 versus 6, see, now look at this distance is less compared to the previous one. I mean previous one means I'm talking these versus this. So this is more distance and this is less distance. This is one part. So hydrogen bonding, if it is closer, then that's better, more stable. And ideal, this is not a cyclohexane ring because there is one sp2 carbon which increases the bond angle too. So that's why this hydrogen bonding is not that much stabilizing like this molecule. Actually this molecule has a name, lactic acid. And this molecule is really interesting because the alpha center is actually a chiral center. Apart from that, no molecule here among these 4 options optically active. So it is not. Even if you look at here 1 2 3 4, 5, 6, 7. 7 members. Beyond 6 member there is some strain also, but that's why it is not also that much stable. And the minus I effect vanishes when you go away from this to this position, even here. So gradually minus I decreases. So who is maximum acidic? Obviously option B, or lactic acid is maximum acidic. And this statement is actually verified by the pKa value. Remember the thumb rule: lower the pKa value, higher the acidity. So here, since the lactic acid has lowest pKa value 3.86, so it is maximum acidic. Who is the next? Next is obviously here this butyric. Why? Because some withdrawing is there. You can expect that, sir, what is the next? So lowest value, then 4.75, this one, and next is this one. By the way, student, it is confusing, so it will not be asked that what is the trend or order among these molecules. There is a very less difference, 4.72 versus 4.75. So it is very difficult to determine or conclude. So what is the answer of today's discussion? Option B, lactic acid is strongest acid. That's why it has the lowest pKa value. So this is the end of discussion. I believe this is very useful. Thanks for watching. See you in my next video. Bye bye.